Hello, everyone. Let's start off with our bell ringer question today. Is the following equation balanced? If it is not, what is the balanced equation? Aluminum plus HCl or hydrochloric acid yields aluminum chloride plus hydrogen. And I'll give you a hint. If you start looking at the hydrogen, that's a good place to determine if the equation is balanced, and if it's not, it's a good place to start playing with coefficients. This one was maybe a little trickier than some of the other ones you've done, but hopefully you were able to come up with the balanced equation of 2 aluminum plus 6 hydrochloric acid yields 2 aluminum chloride plus 3 hydrogen. So when we look at the hydrogen, we can see that there's only one in our reactants on the left side of our arrow, and there's 2 in our products on the right side of our arrow. So we know immediately that it's not a balanced equation. And if we start by manipulating the coefficients, so the numbers in front of all of our different elements and compounds, then we can eventually work out that we need 2 aluminum, 6 hydrochloric acid, 2 aluminum chlorides, and 3 hydrogens. The 3 hydrogen diatomic hydrogens. It's always important to pay attention to both the subscript. Remember, that tells us how many atoms are in that particular compound. And then our coefficients, which tells us how many of those compounds are in our reaction as a whole. Today, we're going to be talking about different types of chemical reactions. And our learning objectives are: I can identify 5 different types of chemical reactions, and I can describe the patterns of reactants and products in each of those types of chemical reactions. So when we talk about chemical reactions, there's 5 main types that we think about. There are a few more, and sometimes some of the main types have different slight variations, but these are the 5 that we are going to talk about today. So let's start with synthesis. Synthesis reactions are when 2 or more substances combine to form one compound, just like you see over here. We have compound A, compound B, reacting to form a new compound. Synthesis reactions have multiple reactants, but they form one product. And if we look at this example right here, the formation of water is a good example of a synthesis reaction. We start off with 2 diatomic hydrogen, 1 diatomic oxygen, then they react. Remember, the arrow means results in or yields, and then we have water, 2H2O. So that's a synthesis reaction. 2 or more substances combined to form one compound. Now let's take a look at decomposition. Decomposition reactions are pretty much the opposite of a synthesis reaction. It's when we start with one compound and it breaks down to form 2 or more different substances. So again, just like right here, we start with one compound. It's made up of multiple different types of atoms or molecules, and it breaks down into other compounds. We always form at least 2 products with a decomposition. We can start with multiple, but we always form at least 2 products. And as I said, it's the reverse of synthesis. And if we take a look at our example right here, this is the decomposition of ammonia, or NH3. So again, in order to balance our equation, we have to start off with 2 NH3, and then that breaks down and yields nitrogen gas, diatomic nitrogen, and 3 hydrogen, diatomic hydrogen molecules. And that's decomposition. So decomposition is when one compound breaks down and forms 2 or more substances. Now let's take a look at single replacement. Single replacement reactions get a little bit more complex. Single replacement reactions are when one element replaces another element in a compound. So if you look at this diagram up here, we start off with a compound of a blue circle and a green square. We add the pink triangle, and the pink triangle is going to switch with the green square. So we end up with a blue circle bonded to a pink triangle, and then we've got leftover green square. In a single replacement reaction, we usually have some sort of an element that's reacting with a compound. If we look at our diagram right down here, we can see a really good example of how one element reacts with the compound, and then the elements switch places. I apologize, my head's kind of in the way right here. But we start off with an iron nail. Fe is the periodic symbol for iron. And here we've got a solution of copper sulfate. SO4 is sulfate. So when that nail sits in the copper sulfate, it's given enough time, the iron and the copper are actually going to switch places. So this nail is going to have a color change. It's going to be copper colored because that's the copper replacing those iron atoms. And then the solution is going to change color as well. It's going to go from blue when the copper is dissolved in it to kind of a yellowy green color when it switches with the iron. So our reaction would look like iron, Fe, plus copper sulfate yields copper plus iron sulfate. So there you have it. A single replacement reaction is when one element replaces another element in a compound. Now let's take a look at double replacement. If you're thinking that double replacement sounds a lot like single replacement, you're quite right, but it's a little bit more complex yet. In a double replacement reaction, negative ions, so ions that have an extra electron, because we've added an electron, so we've added a negative charge. Remember, we need to be thinking back to our other units to make connections. When negative ions in two compounds switch places and form two new compounds. So if we look at the diagram right here on the top, we've got the blue circle and the green square, and the pink triangle with the orange pentagon. In this instance, our square and our pentagon are going to switch places. And we're going to end up with our products of blue circle, orange pentagon, and pink triangle, green square. See how our green square and our orange pentagon just swapped? That's exactly what a double replacement reaction is. In a double replacement reaction, we always have two compounds that are reacting, and we're going to end up with two compounds that form. So if we look at our example right down here, we're seeing that copper sulfate again, and this time we're adding it to sodium hydroxide. So 2NaOH, 2 sodium hydroxide plus copper sulfate is going to end up with copper hydroxide and sodium sulfate. That's the value. This Na2SO4 is what's hiding behind me right now. So there you have it. We take our copper sulfate and our sodium hydroxide, and we're actually going to switch our copper and our sodium. A double replacement reaction is when ions in two compounds switch and form two new compounds. So we've covered a lot of ground already. We've talked about synthesis, decomposition, single replacement, double replacement, and we only have one left now. We're going to talk about combustion. Combustion reactions, hopefully you're able to kind of make a connection to the word combustion. If you think of the word combustion, what do you think of? You might be saying you're thinking of burning or an explosion, and that's exactly right. Combustion reactions are when substances combine with oxygen and release energy. So when we think of a release of energy, that energy can be in the form of light, it can be in the form of sound, it can be in the form of heat. Those are common ways that we see energy released in a combustion reaction. And the most common form of combustion reactions that we talk about is the burning of hydrocarbons. So hydrocarbons, I hope you're making those connections again. Hydrocarbons are made of hydrogen and carbon and nothing else. Hydrocarbons, hydrogen and carbon. And that's a very common example, like I said, of a combustion reaction. So we look up here, we're always going to, when we think about our most common combustion reactions, we're going to start with a hydrocarbon, we're going to add oxygen, and then we're going to end up with our products. So it's going to yield carbon dioxide, CO2, and water, H2O. Why do you think that would happen? Why are we going to end up with carbon dioxide and water if we're starting with hydrocarbons and oxygen? Well, if you look down at the example right here, where we start off with 1 molecule of methane, 2 molecules of oxygen, and then we end up with 1 molecule of carbon dioxide and then 2 molecules of water, hopefully you're able to see just how this makes sense. Our hydrocarbon, our methane, is made of carbon and hydrogen, and those atoms are all going to rearrange so that we end up, when we combine with the oxygen, we're going to mix our carbon with our oxygen, and we're also going to mix our hydrogens with our oxygen. So we're going to end up with carbon dioxide and water. And there you have it, all 5 different types of chemical reactions. And to review, a combustion reaction is when a substance combines with oxygen and releases energy. Synthesis is when 2 or more substances combine and form 1 compound. Decomposition is when 1 compound breaks down and forms 2 or more substances. Single replacement reactions are when 1 element replaces another element in a compound. And double replacement reactions are when ions in 2 compounds switch and form 2 new compounds. All right, I wanted to go through a little bit of the assignment because I want to make sure that we are all doing it correctly. So today your assignment is going to look something like this, not exactly like this. This is my version. And what I want you to do is I want you to list out the 5 types of reactions, and then I want you to describe the pattern of reactants and products that we usually see for that type of reaction. So that should look a little something like this. I'm going to start off with my type of reaction, and I'm going to start off with synthesis. So I'm going to write synthesis in this box. And yes, you can copy what I write for the first one, but I'm only going to do the first one with you. So for the next box, you would write a different type of reaction that we talked about today, and then you would fill out all 5. But now that I know that I'm starting with synthesis, I want to think of the product or the patterns that I see for the reactants in synthesis. Well, I know that a synthesis reaction is when I combine something and I end up with a new product. I end up with a new compound. And if I remember correctly, with synthesis, I always start with 2 or more reactants. So this is going to be on the left side of my arrow. I start off with at least 2 reactants. And then when I'm synthesizing, those reactants are going to combine and they're going to form just 1 product. So I would write at least 2 reactants yields 1 product. So I'm going to practice using that word yields because I know that that's a scientific word that I'm going to have to keep using over and over again. So this is an example for synthesis. You need to do the same sort of thing for the other 4 reactions, making sure that you are defining the pattern that we see for reactants and products for each of those reactions. This column over here will have different answers for every single box. Alrighty, good luck, and if you need help, send me an email or book a time with me during office hours.